Dear students, according to our lesson plan, today we are going to discuss about hyperbola. That is your chapter 6C. And in this chapter, we'll discuss first some basic part of the hyperbola. Then we'll try to understand what is the basic figure of the hyperbola, and we'll going for some formula, then going for some problem solution. So first we have here actually drawn two figures of hyperbola. Maybe you can't understand why we are going for that, but don't worry, we are going for first the formula, or what's the standard equation of the hyperbola is. Standard equation of hyperbola, it's actually looking like x square by a square minus y square by b square equals to 1. That is the standard equation of hyperbola. So x square by a square minus y square by b square equal 1. And for these types of hyperbola, we will going for a standard equation, that is x square by a square. We will be going for the left part or right part, and here it will be y square by b square minus cos to 1. So that should be the standard form of these types of hyperbola. So my dear students, actually in these two types of equations are very much looking like similar to the ellipse, but at the ellipse there was plus, but here it will be minus. Okay, and especially on that ellipse we are going for some one thing, that is a major or minor part, that was a and b, that was depending. Okay, if a was bigger than b or b was greater than a, on that time we have some seen some actual variations, but here there is no types of variation on that types. Here we are just looking for which one is come first. Who will come first, those will be the bigger. Clear? Okay, now we are going for some formulas to understand the all the things. Say for example vertex, center, foci and something like that. Okay, we will going for now that part. So first we are going for here what's the coordinate of center. So the coordinate of center should have been 0 0. So here center will be looking like in this part. We will just talk about this part, then we'll convert it into this. Okay, so center should be 0 0 as like as the ellipse. Secondly, we're going for what is the coordinate of the this foci. Coordinate of, yeah, it should be the vertex actually. Coordinate of the vertex should be, coordinate of vertex should be plus minus a comma 0. Then we're going for the foci. Here it is plus minus a comma 0. You can understand that this is the vertex, and here is also a vertex. So all two are the vertices. So these two are the vertices, and then we're going for our third part, that is foci. So here is the foci and here is the another foci. So the coordinate of foci should be plus minus ae comma 0. That is the foci. Okay, so to understand this part, now we're going for what's the distance between these two foci. So the distance between two foci should be distance between foci or two focus, distance between two focus should be 2ae. So this is the distance between two focus should be this. So here we can understand that center, then vertex, then focus, then distance between two foci. Okay, after understanding this part, we will going for what actually the E. E is the eccentricity, and in these types of part or the hyperbola, we know that eccentricity must be greater than 1. Eccentricity must be greater than 1. If eccentricity must be greater than 1, then we can say our eccentricity should have been root over a square minus b square by a square. That is, it can be written as root over 1 minus b square by a square. It was the for the ellipse, but at the case of this hyperbola, it should have been plus. So a square plus b square by a square, or root over 1 minus b square by a square. It is the eccentricity of the hyperbola. Then directrix. What should be the directrix? The directrix should be generally it can be coming from here and here. So there is two directrix. So the coordinate of the directrix should be plus minus a over e comma 0. So this is the directrix, and the distance between two directrix should be distance between two directrix. Distance between two directrix should have been plus minus AE. It was AE, so the distance should be 2A by E. So this is the distance between two directrices. So my dear students, we can find some the formula from this figure. First is center, then vertex, then foci, then distance between two focus, eccentricity, then directrix, and distance between two directrices we have found by this way. So here is some another part is there, but since our actually there are space limitations, so we'll going for this part. Okay, so here it was on the x-axis plane actually, but here it is on the y-axis plane. That's why it has been changed into this part. Just two things. One is x will be converted with y, and a will be converted with b. So at the place of x you will write y, at the place of a you will be write b. If you doing that, then you have done that all. So center should be 0 0, and here these types of part you will get again center is 0 0. Here you have found the vertex is plus minus a comma 0, you will get actually 0 comma plus minus b. Foci was plus minus a comma 0, but here you will get actually foci should be 0 comma plus minus be. Okay, then it was actually the distance to AE, and the distance should be to BE. Here eccentricity was that, and here eccentricity should be root over 1 minus a square, a square by b square. So it was the eccentricity for these equations. Okay, and here directrix was a by e comma 0, and here you will get 0 comma plus minus b by e, and the distance between two directrices was actually that, and here you will get actually 2b by e. So these are the part where we can very easily convert it into x plane into y plane by two sense. One is x will be changed with y and a will be interchanged with b. Then done. So I think you can understand that how we can convert this part into that. At the same time, these are not the all, so we're now going for the another part. But I wanted to mention in here one thing, that from ellipse there is some difference, and the difference is very simple. That is, here it was minus, but in the ellipse it was plus, but here we have find that it is minus, and we have find this difference between the eccentricity also, it is actually plus, but at the case of ellipse we got minus. Okay, so now we're going for the another some parts or formulas. Now we're going for length of transverse axis. Length of transverse axis. Length of transverse. Length of transverse axis. Here this is actually the major axis what we are learned in the elliptic part, and here this axis is not the major axis, it is called as the transverse axis. So we know the length of these two transverse axis is nothing but the, because it was a and it was a, so it is actually 2a. Okay, and length of the conjugate axis, and on the elliptic part we were known as the minor axis or conjugate axis is 2b. Similarly, here we can very clearly understand that here it is the major axis, or in the actually hyperbola we known it or called it as transverse axis. It should be 2b because on that part, and conjugate axis was 2b for the this part, and here it should be 2a. So this is the transverse and conjugate axis part where we'll get some actually the difference between elliptic and the hyperbolic part. Then we're going for what's the equation of the transverse equation and what is the equation of the conjugate axis. So equation of transverse axis. So equation of transverse axis should have been here. We can easily understand that here actually in this part we'll get the equation. So equation of transverse axis where we'll not get no y on that part, so it should have been y equal 0. And this part, that was the equation of the conjugate axis. So here it must be x equal 0. And similarly here the transverse axis was there, so on that part there is no x part, so it should be x equal 0, and obviously that should be y equal 0. So we get these two axis, transverse and conjugate, from these two equations. My dear students, you can understand that what's the basic difference between conjugate and the transverse axis, and in this part or in this hyperbolic part we actually know about the transverse and conjugate, which is nothing but the major and minor in the elliptic part. Okay, now we are going for our next two part, that is what actually the lattice rectum. We haven't telling it that what is the lattice rectum. Actually lattice rectum is nothing but a perpendicular line of the distance between if we actually draw a perpendicular line on the foci, then what's the distance of the first the length of it, that is called the lattice rectum. So equation or what's the lattice rectum? So it is actually the length of the lattice rectum. Okay, so it should be 2b square by a, and in this case the lattice rectum should have been changed with b to a. That should be here the lattice rectum can be 2a square by b. Just this will be converted. Here a will be replaced by b and b will be replaced by a. Okay, so lattice rectum we have been found from here, and maybe one question arises in mind is we have find the lattice rectum. Good. So what's the equation of the lattice rectum? So equation is there also for the lattice rectum, that is plus minus ae. So the equation of lattice rectum should have been x equal plus minus ae. That is the equation of lattice rectum. So lattice rectum is x equal plus minus ae. Why? Because here the foci, on foci we are just drawing the lattice rectum. Here on the foci we have actually drawing the lattice rectum. So equation of lattice rectum should have been plus minus ae. And similarly the equation of lattice rectum in here will get actually y equal plus minus be. That is the lattice rectum on this part. Okay, now we'll going for some distance between that two regions. Say for example, what's the distance between this foci to the directrix? So the distance between foci to directrix should have been distance between foci to directrix. It should have been the distance. So it was what? The foci was plus minus ae and the directrix was a by e. So that must have to be ae minus a by e. That is the distance between foci to directrix. And obviously the distance between foci to vertex was what? Foci to vertex. And it should be the foci was AE obviously, and vertex was A, so AE minus A. That is the actually distance between foci to vertex. Clear? And here it should be actually the distance between foci to directrix should be actually BE minus B by E, and this should be actually BE minus B. So we have finally the answer of it. Okay, my dear students, we can understand what actually the formula on it. Then we'll going for some application regarding on these formulas. Okay. So dear students, now here I have been written a actually problem. This is from chapter 6C, question number 2, and the problem is find the length of two axes of conic x square by 9 minus y square by 25 plus 1 equals 0. So here what actually there is talking about, what we need to find actually, that is the length of two axes. We need to find length of two axes. We know how to find out these types of problem very easily. So our solution should have been here is given something. The given conics is x square by 9 minus y square by 25 plus 1 equals 0. So this part could have been written as x square by 3 square minus y square by 25, that is 5 square, equals to minus 1. So after multiplying minus, we will get y square by 5 square minus x square by 3 square equals to 1. So here we can understand that this is not the first part, this is actually the second part's problem. So here our first axis, or this two axis length should have been found. So the length of the two types of axis, one is what, transversal, and another is conjugate. So what is the length of the transverse axis? Can anyone tell me? Obviously I think you can say that what's the length of transverse axis. So length of transverse axis should have been 2b, or here it should be 2 what, b, because that was 2a and 2b, but here we will get actually 2b. So b should be actually looking like this. So 2 into b, it can be actually 2 into 5, because we know it is actually looking like y square by b square minus x square by a square equals to 1, this shape. And the length of the transverse, then the conjugate axis should have been, length of conjugate axis should have been 2 into a, I mean this is 2 into 3, this should be 6. So these two are actually required answer. So my dear students, I think you all can understand that in which way we have find this. If you have any confusion, obviously we can go for the first formulas, then going for the problem. Okay, now we're going for our last problem for this lecture. So dear students, that's our last problem, and this problem is actually talking about find the center, vertex, foci, eccentricity, length of two axes of the hyperbola is this. So from here, this is obviously hyperbola, and here the solution can be looking like given here x square by 5 square plus minus y square by 4 square equals to 1. Just 25 can be written as 5 square and 16 can be written as 4 square. Comparing with this, comparing 1 with x square by a square minus y square by b square, we get a equal 5, b equal 4. Okay, now from here we can write what's the center. Now we know center is actually 0 0, no sense in here. Then vertices should have been, actually it is plus minus a comma 0, so it should be plus minus 5 comma 0. Very easy to find out the vertices because it is just putting the value and there is plus minus 5 comma 0. Then foci, we know foci is plus minus ae comma 0, so plus minus ae, here a is 5, but we know what's the e is, that's why find first the eccentricity e. So here also the eccentricity we have to find. So eccentricity is equals to root over what, a square minus b square by a square minus b square by a square. So it can be written as 1 minus b square is nothing but 16, I mean it should be plus 16 over a square is actually 25, so the answer should have been 25 plus 16 by 5, so it is nothing but the 141 by 25, so 5 root over 41. Okay, so root over 41 by 5, that is the value of the eccentricity, so it should be root over 41 over 5 comma 0, say then 5 gone, it should be plus minus root over 41 comma 0. And finally we have to find one thing, that is the length of the two axes. So what's the length of two axes? Or that means what is the length of the transverse axis and what's the length of the conjugate axis. So the length of transverse axis should have been can be written as here. So length of transverse axis, length of transverse axis is actually what it is 2 into a, that is 2 into 5, that is 10, and length of the conjugate axis is 2 into 4, that is 8. So this 2 is also our answer, everything actually in our answer. So my dear students, I think you all can understand how to solve these types of problem. And obviously you can also understand that how important the formula is. First we need to memorize the formula, and you have already solved parabola, then ellipse, and now hyperbola. All are the very important part and very easy if you have the sound knowledge on the formula. So first focus on the formula, then going for the maths. Hopefully it's very easier for you. So stay safe, remain healthy. Thank you very much.